Yep. So again, I'll do that over again just to make sure. So if you go to help and the getting started here, or the help, this CAM350 menu map, I highly recommend it if you're just getting used to where things are in 14.x and you're used to 12 and previous to that. So you can print this out or print it to PDF and keep it handy. Some other things that changed in the interface and I think that are important to look at are the inclusion of all the tables at the bottom of the screen. Sorry, I'm trying to get this to auto hide here. All right, that should do it. Well, if it won't, we'll just resize here. All right, I wanted you to be able to see the bottom of the screen. That's why I did that there. So, again, one of the biggest changes was the collection of all of the tables throughout the tool and placing them in one location. So, you know, you got system messages in one area. If you wanted to see a layers table, you had to go to another menu. If you wanted to see parts, you had to go to additional menu. And you were jumping through all these different menus just to see items that were in a table. So one of the things we did with this release is include all the tables in one centralized location. Now, I'll be honest with you, this is not the way I use CAM350. I pull this off of here, and I put it down here, just so I have the biggest real estate possible for the actual data. I do the same thing with the layer display. I pull it off as well. So my CAM350, when I'm really working on something, looks more like this, and I'll just expand it a little here, and expand that one. So you can kind of get an idea how you can customize this. You can always redock. If you pick this up and you get these little things, that's where it's going to go in the dock. So you can always redock your panes, we call them, wherever you like on your system, okay? Now, another thing I don't use is the world view, so I just turn it off. And again, that's personal preference, up to you, however you want to, do this. You can also do the same thing for the selection filter over here on the right. I have it set to auto hide, but again, I could just, pick it up. I can dock it, or I can just place it somewhere. And to be honest with you, where I usually place this is right back over here as well, is on top of this this area here. But for now, I'm just going to leave it over there, and I'm going to let it auto hide. So these are controls that you have for your workspace to try to make those as usable as possible. So again, I would encourage you to experiment with that. It will remember from session to session where you put everything. If you want to bring something back, I know a lot of our users, the first thing they did when they saw the tables down here at the bottom was turn them all off. And you can do that with this X one by one. But to turn them back on, you've got two choices. You can go over here to View and Panes and choose the ones you want to put back on. So if I want to turn World View back on, or if I want to put it somewhere else, all these things are available to me, or if I just want to get rid of it, I can hit the X. But you can always bring them back. If you've deleted a lot of these and you want to bring them all back, then the easy way to do that is another new feature in 14.x, and that is the options dialog. So very similar to tables, the options dialog gathered all of the various settings that you could make in the older versions and puts them in one location. So, it used to be to turn, I'll give you an example, and you've probably seen this with ODB data that has components. And you don't want to see the component outlines. In 12.2, you had to go to Settings, View Options, and then uncheck the boxes to to see those. Same idea here, but it's all in one location. So if I go to CAM Editor, and I can turn off Show Part Outlines, and they will not show. Now, I will caution you about this dialog. You want to make customizations without a design loaded, and then you'll set those as your default. And then you can always restore defaults as well down here. Okay, so there's a lot of controls. I'm just going to go through a few of them here just to give you a kind of a broad sense of what's in here. So what do you like your cursor to look like? What does the middle mouse button do? Okay. We have a lot of CAD users, a lot of people that use design software, and the way a program like an Allegro or an Expedition work with the mouse is different than the way CAM350 works with the mouse. So we put in an additional mouse mode if you prefer that other way of doing things, the way CAD systems do. When you bring in ODB or 2581, those formats now support dielectric layers. So you'll see those in your layer display table. Well, if you don't want to see them, you can turn them off here under Hide Dielectric Layers. Okay, and there's a few more controls to that. Your color controls. A new one in 14.5 is you can turn the board outline on or off or change the color of it. We use it extensively. We use it for panelization. We use it for DFF. It's an important feature to have a true board outline, but the request we used to get was people just wanted to turn it off, so we did give you a way to turn it off here. Other new features are the abilities to show net names, decodes, and PIN numbers right on top of the feature. You can turn that on or off here, and there's actually a couple other places you can do that. I'll show you those as we go through the demo here. And again, I'm just hitting some of the points. I'm not trying to show you everything in here. So if you were familiar with where you set preferences over in the older version, basically all that's here. Your snapping capabilities. I have snap to object turned on, snap to grid turned off, and if I go to grid, you can see I have it turned off as well. Now you may want to show it, it's up to you. But again, these are the defaults that I've set. And then your measurement units. I'm pretty sure you all are working in metric units, so you would switch to metric. I'm going to do English right now. It's your choice. Again, pick the one that you want to use. License usage, this will tell you what your license you have. So one last thing in here, and it has to do with analysis. All the analysis is done via the streams checklist now. I say that, but there is an additional way to do it. But we used to have that form that you filled out in 12.2, and it wasn't very robust. You couldn't set up generic layers and have it work with generic layers. It would only support one drill file. There were many problems with it. So what we did when we went to 14.x is we took all the checks that were in that form. Again, think of, you know what, I'll even bring it up, just so we really are understanding what we're talking about here. So all the checks that are in this form that I'm going to bring up are now available to you in Streams Checklist in 14.x. So whether you used to go to Analysis, DRC, and you had this little form, there's 13 checks in here. Well, we took these 13 and we added about 6 or 7 more, and all of those checks are available to you now in 14.x if you have a 160. If you had the 520, you would get all 120 different checks that will run. But since you have a 160, there's about 20 checks you get. Those will be enabled, and everything else will be grayed out in a 160 bundle. And where I was in that options dialog, I just want to go back to it for 1 second. In the Streams editor, we include a default stream, so that is a checklist, so that anytime I go into Streams, the editor here, I'm going to see that particular checklist. Now, you may have multiple checklists. It's entirely up to you. But we include this one. It did come from a major board shop here in the US, but as you can see, the only things that are enabled are the ones that are included in the 160 license. Everything else is grayed out. but you can still use this to run your analysis. So basically load a design, come in here and run analysis. That's how easy it should be. You can always choose a different checklist if you want to, if you have more than one. Maybe you have one that's specific for different technologies, or you have one that's for flex versus rigid, however you want to break them up, really. And to modify this is just as simple as, first of all, you can click into this spreadsheet mode, and if I wanted to change that one value, I could. Or I can use this matrix out here to change multiple values. You can set a value and then say apply to whatever you have enabled here. Okay, so different ways of modifying the analysis that's being done. But the advantage to using streams to run analysis is that if you have multiple drills especially, it knows which layers those are going through. And we're going to go through that process right now of how we get there. But the thing I really wanted to impart there was that there is a default stream. You don't have to use it, but we include that, and that's a good starting point for a lot of people to modify their capabilities so that they can run them against designs. All right, so the next thing I'm going to do is I'm actually going to import some data here, and let's bring in some Gerber to start off with. So we'll just use the auto import, and this really hasn't changed over the years. Now, one thing you can do, and I don't know if you do, is use the template editor to look at file names. Often this is kind of overkill for fab because you're getting data from all different sources, and the file names could be different from each company that you're getting the data from. But I've also seen fab shops that have 100 different templates here, and it will go and look for the one that best matches the pattern that it sees. What it's doing is it's actually setting the layer types as the key. It also can set the colors for you. So when I hit next, and again, you select the directory just like you always do, you hit next. Because I used that template, it was able to label the layer types here, which is important later on. Any kind of analysis, if you want to view the design in the correct order, or if you even want to look at the design in 3D, that's important that you put the layers in the correct order. Now, one thing you can do is if you don't use a template is you can label the layers at this point. Okay, you can set the layer types while you're importing. You can always do it after the fact, but it's best to do it during the load process, because the next step goes right along with that. Is once I have these set, it takes me to a new feature called the Stack Up Visualizer, where basically instead of having to go and tell the software that I have this drill file only goes through layers 1 to 3, and having to click on, as you did in the past, layer 1, layer 2, layer 3, and then you'd have to do the same for this one and same for this one. It's just a drag operation. So I just drag that up there to indicate that the drills are going through the proper layers. And I could do that for all 3 of my partial drills here. So it's a much easier way to load the data than it was and get to the point of having an intelligent netlist extracted and the data in the correct order. I can also change the dielectrics here. I'm not going to go into that now, but that can be something you may think about in the future, especially if some of your customers use CAM350 or Allegro. But let's just leave that for now. The next thing I'm going to talk about is the drill files down here, and you can set the plating characteristics. And the reason you would do that is so that when you run any analysis, that it knows whether the drills are plated or unplated. Now, this particular design has a separate unplated layer, so you can see I made it that way. By the way, there's nothing in the drill file that tells us if it's plated or not. That's not per the Exelon spec. Some drill files have comments, but they're not per any spec. So when you load a drill file, you have to tell the software whether a hole is plated or not. Now, I'm doing it at the layer level here. That's not always possible. As you know, a lot of times you get drill files with all the drills in one drill file, plated or non-plated. But you can do that out at the drill and mills table to change the plating characteristics. But by doing it here, it just gives us a little head start. I hit finish. And another new feature of this particular release is that it will prompt you to run netlist extract at the end of this. It's always a good practice. You're going to get less false errors when you run analysis, and it's going to extract a netlist and load the data. Okay, and as you can see here, it went through under nets now. I have all these nets that were extracted. I could go find any of them if I wanted to, just by clicking on them. So AutoFit's going to fit it on your screen. AutoFind's going to search through all the layers. If you just want to search on one layer for a net, you don't turn AutoFind on. You just turn AutoFit on. And then Highlight turns the highlight on and off. Okay? And I believe Control click on some of these will also turn it on and off. There we go. So those are some of the things, and this is the Gerber extracted net list. So basically all I did, and I can do this for Gerbers, I could do it for ODB, I could even do it for IPC 2581, all I did was extract a net list from the graphics because I want to compare it to the IPC net list, which is probably the most important analysis you can do on a design. You'll also notice that it put the net names onto the traces here. Okay, that's another new feature. You can turn that on or off over here under the view ribbon. Let's see here. Let's turn on layer 1. And if I zoom in enough, you'll start to see the net names. And if I zoom out, you can see that. Decodes can be turned on or off. If you're going to do any editing, it's kind of cool to have the decode right there. And then if we load intelligent data, I could actually turn on the pin numbers there, and it would show me the pin numbers for the components. Probably not important in Fab. But again, I've extracted a netlist from the graphics. In the same directory was an IPC D356A file. So it loaded that when it loaded the graphics, the drill, and the Gerber layers. So that's in here as well. So really all I need to do to run comparison is go up here to the Analyze ribbon, go to External Nets, and run this. But the reality of that is I've already done this step, which is browse to the 356. I've already loaded it. And I've already done this step, extract a netlist from the graphics. So all that's left is to do the comparison. So I could just go in here and simply say run, and it goes ahead and it compares the graphics, the netlist from the graphics to the IPC netlist, which came from the CAD system. So now we know that at least electrically, the design matches the design intent. Yeah, we may have pads too big, spaces too small, something like that, but electrically, it matches what the designer was trying to do. So to me, as a former fabricator, this is the single most important analysis I can run on a design. And it's available in the 160, it's available in the higher end, it's available for you. So if you're not doing it, I imagine you are, but if you're not, I highly encourage it. We've added some enhancements to this over the years. Some CAD systems will group all of their nets that don't have a, these are single point nets that don't have a net name into their own group. Some CAD systems call it NONE, some of them are just N/C. Well, you can put that in here and it will ignore it when doing the comparison so that you don't get a lot of false opens basically for the nets that are all with the same name but aren't connected. This is the way some CAD systems output it. Okay, but that's basically netlist comparison, which is the first kind of analysis and highly recommended. Again, my old board shop required it, by the way. You had to send a 356 netlist or you signed a release that we could not guarantee the quality of the design. All right, so I've done that, and now maybe I want to enhance the intelligence of the Gerber and NC. So what I can do, since I got a good netlist compare, is I can go over to Netlist Tools, and I can tell it to override the CAM net names. So it's going to pull those intelligent net names from here, from the IPC, and then override the Gerber extracted net names with those. So as soon as I do this, you'll see them update, And now we have something that makes sense when you're feeding back to your customer. You can tell him that, you know, dip switch 11 track was too close to dip switch 10 track. So you can use verbiage that he's familiar with when you feed back that info. It's not a requirement by any means. As a matter of fact, I probably have only about 20% of my users using that feature, but I think it's quite nice in that when you are talking with your customer, you can use this. He doesn't know what net 1, net 2, net 3 are, so if you try to tell him that you got a short between net 1 and net 3, he's not going to know what you're talking about. Okay, so anyway, that's just another setup item that you can do. As you can see, as I move the mouse around, I no longer really have to do the query command because it queries for me. I get these tooltips as I move the mouse around the data, and it tells me exactly what it is. Query command still works, the hotkey Q still works, but really it's almost unnecessary these days, unless you just really want to make sure it's querying the item, you know, if you're zoomed way out like I am. There is a layers table in here, which mimics what we used to have in older versions, but the reality is it's almost unnecessary. We kept it around for legacy purposes because everything I can do here, I can pretty much do over here in the layer display table. If I right click, you'll see there's a lot of options that I can do over here. So in my day-to-day operation, I never look at this. As a matter of fact, I could turn it off and probably never need it again. I can always turn it back on, but that's the layers table. And we kept it again for legacy purposes. Decodes is going to tell you, you know, what decodes are being used, and you can do this again. You can turn on highlight and auto fit and auto find and select a decode, and it'll go look for it out here, either on this layer or on all layers. Again, another way to find information. I noticed some of the items in your list, you were talking about finding different features. That's a way to do it. But also under the home ribbon, there's a find option, and this has been enhanced with this particular release. Since it's Gerber and NC, obviously RefDes doesn't work, but I can go to decodes, for instance, and pick a particular decode. And again, I have the auto fit and auto find, and I can just tell it, go find that. Or you know what? It's not used on this layer. But if I hit the auto find along with one of these, it might go out and find it on another layer if it is used. So this is just up to you, a user, how you want to use these features. But the find command is another option for going to look. I find, again, I don't use it. I come down here, go to the decode list. It's in order. You know, if I want to find out what decode this is, or if I want to sort by size, I can do that down here and just pick an item and then tell it to go find that item and find what layer it's used on, and it'll go out and look and highlight it for me. Okay. So you can see as I'm clicking through all these items, it is highlighting them for me. So again, it's personal preference, but I find that just doing it out of this list probably works a little bit better and quicker than using the find command up here. System messages, that just basically tells you when they were loading, if they found any problems. Found a couple problems with ARCs that it fixed while it was loading. If you have self-intersecting polygons and you told it either to fix it or not fix it, that information will show in the system messages as well. Okay, so this was very similar to what we had. It was actually its own toolbar, I think, in 12.2, but it's just part of the tables down here in this one. My drill and mill tools, again, if I wanted to change a plating characteristic of something, but since I did it at the loading stage, you'll notice that that unplated drill is already listed as unplated. Now, if I had combination on this layer, let's just say this 85 was a non-plate, I could go in here and change it to unplated. Okay. So there's some other things in drill and mills too, but this would be more for the advanced DFM. You can actually set the hole type, and one of the hole types is laser via or via, and by setting that, then a different set of analysis will be run in the higher end analysis. In the 160, all analysis basically just runs on whatever you've got, but In the higher end, you can say, this is a laser via, so therefore I only need, say, 3 mils annular ring, or this is a mechanical via and I only need, say, 5 mil annular ring. You could have those separate in the higher end one. So just up to you again. You know, there's nothing wrong with the 160. It does quite a bit for what we've, what we charge for it actually. But if you do get into the higher end DFM, you do have this option, and there's even some things that'll run before it runs analysis that'll do that automatically for you. So let me go quickly to analyze, and we've already looked at these couple options here. One of the things you can do under Analyze is layer compare in the 160. You just basically pick 2 layers that you want to compare and run it. If it's a different revision, you could just import that Gerber and then just go ahead and run it. In the higher end, the DFM, there is a design compare, which will actually take 2 full designs and run the comparison. So it goes through each set of layers all the way through it in one swoop, if you will, as opposed to having to go through each set individually. And then we get into the other analysis capabilities, which is your DRC and your manufacturing rules. And again, because it is the 160, the only thing it's enabled in here is, in this case, 1 annular ring check. Okay, and I can set that value and then run annular ring. If I had the higher end, I could have a different value for via pads, which would be the mechanicals. And if I've set up any laser vias, they could have their own, or I could have different values for buried and blind. It's up to me how I set that up, but again, pointing out the differences between the two. This cleanse data is relatively new in that we put all the cleanse operations into one little ribbon or pane here. So some of these you can see are enabled, some are not enabled. That you can do before you go ahead and run analysis. Now, when we were in the streams editor, that same cleanup of the things that will work in the 160 was already enabled, and it will run if I go out and run this right now. Not going to run it because I want to do one more thing, but just be aware of that part. When you load Gerber and NC, you may have a layer defined as a border, or it just might be on another layer. And what you can do is you can tell the software that the reality is this border is, the center of this border is the board edge. So we have a utility for that. It's under the tools ribbon, right underneath it here, draw objects, draw to board outline. So I just basically click on this, right click to confirm, say okay, and it adds that line in there. And I mentioned this early, that we'll use that now if we do copper to board edge checks. We'll use that for panelization, to whether we use the fast array module or the panel editor to properly space the boards between each other. We use that. So before I run any analysis, I will often, and actually I usually make it part of my setup process, I will do this so that when I am ready to run analysis, one of the options here is to run only inside the board outline. So if I had title blocks or crop marks or anything outside of that, it would ignore them when running analysis. Okay. Now, in a fab environment, you probably do some sort of cleanup at some point where you remove all that. So it's not as big an issue to you as it might be for a designer that's running analysis. But you could have a pre-engineering. I don't know if you did this. I used to have a pre-engineer that she would take the designs from the quoting people and run a quick analysis, kind of like the DRC on it, even before the quoting stage. And you could use some feature like that in that. When you run analysis, whether it be netlist compare, layer compare, any of these interactive analysis, the streams editor checklist, the results all show in one location now. Okay, and that's what this is down here. It was our last tab across here. So this is the Air Explorer. So if I want to go view a particular air, I can just go out, click on it, and it'll take me right to that air. If I want to view a group of airs, I can do that through the annular ring check here, and what I'll do is I'll highlight the header and I'll hit Air Chart, and it'll actually give me an air chart based off of this, a bar chart. So if I zoom in here, you can see that 312 of these airs are the same value, 6 are this value, which looks like 0, and then I got one out here that has a really small value. It's a little hard to get the mouse over. There it was, 4.3 mils. All right, so we're in a 160 environment. We only have the one annular ring check, right? But we can look and see, well, wait a second, and we'll just click on one here just so you can see it. That was a 8 mil drill with a 15 mil pad. Well, that's a via, obviously. So I'm going to teardrop those anyway. So you know what, 3.5 is enough, and I'm just making the decisions here. 3.5 is enough annular ring. I can right-click and validate those. So those errors go away, actually just the one, unless I'm just choosing the header here, so let me do that. Okay, so now I'm going to select them all. See how it highlights them all here? And then I right-click on it and validate it. And it puts that checkbox on them. It shows that they're validated. As a matter of fact, I can even hide the validated errors. And what does that do for me? Well, what it does is it actually tells me that I've gone through and validated a bunch of errors, and then I have these left that I have to deal with. And so I've got a plated through hole that has a pad, an 85 pad with an 85 drill. Okay, and then I've got some 100 mil holes. These are non-plates with 40 mil pads. Okay, another difference in the 160 is we would have split that up in the higher end, so they wouldn't have failed the regular annular ring. They would have been if you ran non-plated annular ring, they would have been in there. Most people don't even run that, so they wouldn't have shown it all. It's basically just that, what we call a spot pad. Okay. So that is our options as far as running the analysis through the checklist. And there's other things you can do with this, but you get various errors. Again, they're going to be the same ones that that you would have gotten in the old DRC form, but here we're doing it in a checklist. I can split up inners and outers and do these specialized checks on, and actually you typically only do those on inners, but I can do the specialized checks as well. Or excuse me, only on outers. Yeah, so that's correct. So anyway, the whole idea is that I can run analysis and just using the items that I have, but I can use this checklist to do it. And there's more features and functionality for that, but I don't want to spend the whole time on analysis. You had a bunch of other questions. So again, once I click in here, I get this little matrix over here. But if I zoom or if I scroll down, I also have filtering capabilities. I can filter in and out by decode or layers or even areas. One of the things that we did add for the 160 user in the latest bundle is the ability to define areas. So if the minimum spacing in the BGA area is different than the rest of the board, I can verify that. So I simply just go draw an area around my BGA, and then when I'm setting up my analysis items, I can, in streams, I can just choose, and we're done with this, I can choose to run either just in that area by using the area filter here. I can say run everything, or I can say just run in this area. Or what I can do is say run in everything but negate that area. So now it's running on everything except for that area. Now this is typically more for the designer because they're verifying or validating constraints by area. But still, there's times when you'll find uses for it, I think, here in as a fabricator as well. But areas is another capability of the tool. All right. So that's a quick overview of analysis and getting to that point, loading Gerber and NC. As we debug certain PCB circuits, we need to see certain signals where it passes to know if it's beside circuits. So you've got a few choices there. I think probably one of the ones you might use is go out here and find a net, you know, and then follow that net, whether it's just, you know, something that's real simple like these are, or something that goes through, you know, maybe multiple layers or whatever. But a lot of these are just very simple nets, and you can highlight them here, and then you can go through and turn on the various layers. If you just want to see, you can see that it goes down to that layer and then is connected here. That would be one way to follow a net. You know, you can always just query an item, of course, and it's just going to show you, but if it's segmented, then it's not going to show you everything. And you can see here that when I clicked the second time, it highlighted the entire net. There's that find command, again, that we looked at under the home ribbon, would be another way to go find items. And these are the items that you can go find: nets, decodes. If you bring in intelligent data, you could go find reference designators. Okay, so those are, to me, the ways that I would use to track down where a trace goes through several layers or in several areas. There's also an interesting one that I kind of like that we just kind of put in on a whim, and that's the third measure option here, net to net. So if I have this net here, and I'm just picking a random net, and I want to find the closest point that net comes to, say, this one right here, it'll actually look through the design and actually find the closest point that those two nets come together. So if you had, you know, I don't know, maybe a differential pair that you wanted to keep away from another net or something like that, you could maybe try this net to net, or at least selecting them down here in the nets table. But those would be my recommendations as far as how to follow a circuit. All right, so again, same process: import, auto import. And actually, let me stop here for just a second. If all you want to do is view the Gerbers, let's say maybe you're in the quoting area, just hit no template and finish. And it's just as quick as it was in 12.2. It loads everything, but nothing's set up properly, you know, for doing any kind of analysis. But I do often hear that it was quicker to load data in 12.2. Well, it was if you weren't going to do anything with the data. But if you just want to view the data, it's the same speed, basically, to load up a set of Gerbers here. So let me get rid of that. And I'm just going to load it again here to answer your question. So again, import. I'm going to use best matching template. It finds the template that we wanted, but this time I'm going to tell it not to load the IPC netlist. Next. If I'm going to extract a netlist, I do want these in the proper order. So that part is important. It's the only way that you can understand the connectivity through the design. Okay, and then finish, and it will prompt me to extract a netlist. Well, it should have. If it doesn't, I can go to Analyze, Netlist Tools, Extract CAM Netlist, and just say Run Extraction. So now what it's done, notice there's no external nets here, but I do have a Gerber extracted nets, which I can go find and trace, and you know, everything I was just doing, I can go and look at these. But again, they don't have a, you know, an intelligent net name at this point. But I can go and do that. So if you want to find the closest point, net 3 comes to, you know, net 5, you can turn them on and off and that sort of thing and look at them. But all that was done by loading the design, putting it in the proper order with the proper names, and then extracting a net list. Another thing I should mention while I'm in here is, because I did this and put it in the right order, I actually have a 3D representation of this now, of the Gerber and NC. And what I can do is, let me turn all my layers on here. It'll rebuild this with all the layers on. And it puts it into what's called PCB model mode. It makes it look like a real PCB. So if I zoom in, you can see through holes, you can see into the barrels of holes. It inverts the solder mask so that it, is a clearance as opposed to just a pad. I can switch this over and maybe view the front of it. And then I can turn the dielectrics off if I want to and start spreading layers apart. And this is another way you could follow traces too, is that now if I zoom in, you can even see some of those partial drills show up, and they're not going through all the layers. Okay. So 3D does work with even Gerber and NC, and that's available in all of our products. Okay. Okay, so that's how you would get there if you don't have a reference net list, but you still want to kind of trace, you want to follow traces and so forth. You can query nets at this point and it will follow them. Again, the net name is not going to be intelligent, but you can still do a lot of those same operations there. Okay, I'm going to put this one away for right now, and we'll come back to it. And we'll just continue working here with the other one. And I just wanted to show you a couple more things. If you go to layer sets, this is where I set those layer sets, and you can actually turn on the layers that make up those layer sets. But reality is all that's done in the loading process now, and what controls that is something called the stack-up visualizer. Okay. And this is what I mentioned early on, is that I can have the dielectrics in there. I could change dielectrics. Let's just say to meet the impedance, I decided I needed 12 mils there and maybe 12 mils down here. That's all good and fine for our purposes, maybe our people in-house look at that and so forth, but I can even feed that back to my customer if they have CAM350, Blueprint, or Cadence, because all of those tools will read the IPC 2581 that I can export from here. And it's just the 2581 of the stack-up. So it becomes a tool for communicating stack-ups back and forth between fab and design. And it just takes a little piece of 2581, just the stack-up part, and it writes it out. And those of you that, I don't know if you follow, the 2581 Rev C has just been announced and released, and one of the things it'll have is the ability to do the same thing with your DFF and DRC rules. We're not there yet, of course. We're working on that for future release, but since it was just announced, but that's another thing. So the 2581 will become more prevalent in our industry as things like that get more and more used. As you know, there's a lot of companies out there that just do things like stack-ups, and they sell products, and that's all they do. So that's another reason for using this stack-up visualizer. If you wanted to take it one step further, you could actually have all the materials sitting behind this. You could have your material list sitting behind this so that you would only choose materials that you have in-house and put in that stack-up. Again, you may not want to go this route, but again, these are new possibilities in 14.x. Okay. All right. We'll come back to that in a bit, but that's the stack-up visualizer in a nutshell. What I'm going to do now is actually save this. And let's just throw it out on the desktop. And we'll call this Tuesday. And the reason I wanted to do this is I want to talk about another feature in the downstream universe, if you will, and that's CAM350. I don't think CAM350 gets the amount of use that it could. CAM350 is a free database viewer. It will view the downstream .cam file, and another thing you may or may not be aware of is we actually have a second format now. It's DPD, Downstream Product Database, that you can write out from CAM350, and that's going to be the quote-unquote standard format eventually for all of our tools. But for right now, you can either still do the .cam, and you'll always be able to do a .cam, but this DPD is another option as well. Anyway, so this is CAM350, and the reason I brought it up is that I can now open this design that I was looking at here in CAM350. I can go to those errors. I can add comments to those errors. And when I go to exit this tool, I'm going to show you a few more things in here, but when I go to exit, it's going to prompt me to save. And this is something CAM350 never allowed you to do before, but you can save comments and you can save if you've validated any items. And that works back and forth between CAM350 and CAM350. So it becomes, in a sense, a very nice communication tool. If you have ran a bunch of analysis, and let's just say you wanted your customer to do it, to look at, with any comments you made, all they would have to do is download CAM350. You could send them the database, and they can open it up, make any additional comments, send it back to you. So it becomes a communication tool. I know some of the more expensive tools have HTML and things, but basically you got to hire a scripter, and the software itself is like 6 times what CAM350 costs. So you choose which one works best in your environment. But this is our alternative to that. Okay. Some other things about CAM350. Again, you can do all the commenting. You can go through and validate the results of your analysis. You can click on an error and it'll take you to that error. You can view errors and you can view the actual design in 3D. I actually like the way the errors show in 3D sometimes a little bit better than they do in 2D. So I often jump back and forth between the two. Okay. You can see the whole barrel there, and you can actually see the copper. So again, your choice, but another option as far as viewing. Okay. All right. What I'm going to do now is get out of CAM350, and we're back into CAM350, and let's talk about some of your other questions here. And I'm going to skip the dimensioning to the last one, and you'll understand why when we get there. But how to add a layer and the different types we can add. Are there any? Okay. So whether this layer display is, docked or not, that little plus right there is where you can add a layer. And you can see that it's just adding the layer as I click on it here. And it just makes them graphic by default, but then you could set the type right here. So if you wanted to add maybe an additional solder mask layer, you're doing some sort of specialized solder mask, you could do that. And then if you went back and ran analysis, it would actually run analysis on that solder mask as well as this one here. But that's how you add layers as well as how you can set the layer types. Here's one that's kind of a tip more than anything. If I go in here and select all of these, let me just move it to the center of the screen so it's a little easier to see. If I do a shift select here, I've selected them all, and then I right click, you can see I've got all these options, but one of them is layer properties. And this I often use if I have to manually set my layer types, because what I can do is if I have 16 layers and 14 of them are internals, I can just go in here and choose internal, and it changes them all at one time. Okay, so this layers property dialog gives you a little more power when setting the layer names and layer types. So just be aware of it, and that you can use that as well. All right. Understanding the difference between decode, pad stack, flash, and how to add them or remove them or redefine them, and which situation do we use them? Okay, well, pad stacks is more of a CAD term. When I extracted a netlist, it created pad stacks, which basically is all the pads that are in this design. So if I query this pad stack, hopefully it has something here, you'll get a pull down that shows you what pad is on all the layers in that location. Again, it's more of a CAD concept. I don't think fabricators really care. I never did. So I don't know that you'll need to use those on a day-to-day basis. So I would probably just stay away from using those, and you can even turn it off if you want to down here in the tool. Now, one of the things it does is it sets the hole types based off of the technology of that particular pad stack. So you can see it made some of them blind and some of them buried. And if you have the higher end analysis, it'll pull that forward and use that for running the analysis. But for the 160, I don't know that you would ever really care about pad stacks. Decode is just that. So this goes back to the early days of CAM, and if you've been doing CAM as long as I have, or working with data, which is 35 years now, that decodes were part of the original Gerber specification, RS-274, and then they were carried forward with RS-274X, which is what we use now. And basically every element on this screen is made up of decodes. Okay, so if I do a query decode, for instance, it tells me what that item is. Okay, so depending on what layer I have turned on, if it has a pad stack, it'll show me that, or if it just is looking at a decode, I can see that it's decode 36 and the size is 25. Now, if I want to do any edits, that's information I need. Okay, and we'll come back to that in just a second, but the tool is very centric around decodes, so that you can, if you're going to do edits, you generally need to know the decode of the item you're editing. Okay, so if I just wanted to change that 25 to a 27, the process is typically done through change decode. Okay, but in order to do that, you need to have the new decode you want to use on your system. So again, I could go to the decode list here, but the older way of doing it was through the aperture list, which is the hotkey A, and that'll bring up the aperture table here. And this is really the way you should be doing it. So now what I'm going to do is I'm going to go in here and redefine a new aperture that is a round 27, hit enter and OK, so that now when I go out and I say change decode, first of all, always pay attention to what the software is looking for here. So select a single item, or W for group. Well, if I just want to select one item, I just select it, and then right button to change, and I'm given the decode list, and I pick the decode that I want to change it to, and it changes it. Now, one question you might be asking is, well, why couldn't you have just done, oops, sorry, didn't want to do that. Why couldn't you have just done that in the aperture list? So if I go back to that decode, what was it? Forgot what it was. Let's show them. This is the other thing you can do. You can turn on the decode labels. So if I wanted to change decode 36 as a group to something else, I can do it the same way. Okay, so design, change decode. You might notice the selection filter popped up over here. And that would be something I could use to help me if I wanted to select a particular decode, or another way to do it is if I just wanted to select with a group mode, and maybe I don't want to get draws, I just want to get flashes. So W for group mode. Notice it only selected those. I could have done it a different way. Let me cancel out of here. I could have done change decode and went over and let's pin this selection filter here. And let's go to decodes, and I'm going to turn them all off. I'm going to make this a little bit bigger so you can see it. Clear selection, and then I'm going to go grab decode 36. Okay. And I'm going to go back out here, and I'm going to limit it to flashes, and then I'm going to hit the select all button here. And I must not have done that right. Yeah. Sorry, I turned them back on after I turned them off. Operator error. So decode 36. Okay, and again, draw's not on. I hit a select all, and it just selects all of the decode 36s on what I have on. So that's another way of changing them. And then where I was going with that is the last one is, if I pull up that aperture list, you might say, well, why didn't you just go into decode 36 here and change that to 27? And the reason I don't do that is everywhere that decode is used will now get changed to 27. So it might be on an internal layer. It might be something that I don't want to change. So there are times when you could just change it here, but for the most part, you're going to use that change decode command when you want to change the size of something. Okay, and that kind of goes along with the next question, is modification and manipulation of a pad. As far as the other edit commands go, I think they're pretty straightforward. You know, move, you pick the item, you can use filtering. Notice it's got the trace because I have the net list extracted there. Often if I'm going to be doing editing, I may explode the net list so I don't get more than just the item I want. So let's see here. Let's just try to grab this. If I want to do move, I grab that item, but again, it's getting the trace. I could use the filtering, by the way, to filter some things out. But then you just follow the prompts at the bottom. So select a destination point, and there you go. Okay. So whether I'm moving a pad with traces attached or just moving a pad itself, the move command can work that way on individual items. You can also select multiple items in the move command. When you do that, it asks you for a source point and a destination point. So there's my source and there's my destination. As you can see, I can create a lot of havoc in the editing. Okay. Control Z works, by the way, undo. R is redraw, if you want it to redraw, if the graphics have gotten set a different way. These are all just standard commands. They've been around forever, so you're probably used to them. Flash and draw, I think you understand that, but it is in this question here. So when I'm in any of these edits and I get that filter over here, let's just go back into delete, for instance. You'll notice at the highest level there is draws versus flashes, okay? A polygon is part of a draw, but these could be vector polygons as well. So as you can see, polygons are checked here as well. But generally, a draw is equivalent to a trace, and a flash is equivalent to a pad. So maybe another way to explain that to you might be to bring up a Gerber file and show you in a Gerber file. So let me do that. let's just go to preview here, and if I pull up this in a text editor, you can see commands in here. Well, there's two different types of commands that you might see in here. One of them is just go out, open the shutter, close the shutter. That's what DO2 and DO1 are. So, what that means is, if you don't know this, all a Gerber file is controlling a photo plotter. It's a text file that controls a photo plotter. So what those commands say is open the shutter, put this feature down there, whatever decode it is, close the shutter. But the other type of command you can have is open the shutter, move to a certain location, then close the shutter. That's a trace or a draw, okay? And that's where you start to see these DO3s in here. But so you've got the two options, DO1, DO2, or just open and closing shutters. And this is all in the help system if you really care. But the reason I bring it up, though, is that's the distinction and why we've always distinguished in our tool the difference between draws and flashes is that in a Gerber file, they're distinguished as well. Okay? And we do set the colors. Now, you don't have to do it this way. Again, in that template, you could have it all be one color if you wanted to, or you can go in there and change it yourself. So the draws and flashes are the same. The reason that we did make them different colors 20 years ago, actually it was about 25 years ago, is that a lot of the CAD systems would draw things like these ovals. PADS is notorious for drawing these ovals right here. And if you're going to run any kind of analysis on the design, you want them to be flashes, not draws. So we have a utility called draw to flash, and you would have to run that a lot. Now, as the CAD systems have become more intelligent over the years, you see less and less of that. Still happens in PADS, but in other CAD systems, they've gotten past that point, so you don't need to do that as a user. But that's the reason why we do separate colors over here. And you can control that when you're selecting items with this global filter, or even at the lower level if you just want to pull a particular decode. Okay. So hopefully that explains manipulation and how to manipulate data. While I'm at it, you probably have been here. I think this was in the conversation, but if you go out to YouTube and go to Downstream Tech and go to playlists, we have playlists on all our products. So the current releases would be something like 14.x. As a matter of fact, there is a playlist specifically on this bundle. Okay, so that might be something you may want to watch at some point. But then there's other things, and another one that I'll point out while I'm in here is we did this user group back at the end of October. And some of it is our other tool, Blueprint, but some of it's CAM350. And it shows what's new, how to do an analysis. If you are doing Netlist Compare and you're struggling with it, we had Mike Harris, our lead tech support person, actually do this. And it was just like if we were in a user group, you know, off at some location. We tried to make it look and feel like that. There's GUI tips for CAM350 and then using 3D in both CAM350 and Blueprint. So I recommend taking a look at these as well. So these are just all different things, different playlists, and there's even legacy stuff. And I leave it out there for people that are using older versions, but basically they work the same way. Yeah, the interface might be different, but some of these, you know, are done on an older interface, but they work exactly the same way in this particular release. So, you know, if you haven't, go check out the YouTube site. All right. And again, if you have questions, just throw them out at me, but I'm going to continue on here. How to manage a CAD file and ODB, and how to import and export different file types. All right, so this is a set of Gerber data, and if I wanted to write this out, I can, through the export option, create Gerber data. Obviously, we're going to use 274X. We do want the precision to be at least what we loaded. It can be higher, but you definitely don't want it lower precision than what you loaded, or else you may have differences in, pad locations and things like that. You pick the layers that you want to load or you want to export. You pick where you want to. This is key. So if I wanted to throw these out on the desktop, I would say OK, and then I would hit apply. Okay, and you notice that path changes. If you don't hit that, it's going to put them back to where they got them. Okay. And then you can rename the layers, or you can use file names for layer names. It's up to you, however you want to do that. You can choose which ones get exported. And as a fabricator, you can actually scale these if you want to. So, if you do an offset for, what happens in the press, you can actually do it here when you export data. NC data is exported separately. So again, it knows that that's NC data, and then it has the parameters here. One caution here. Again, I would not export this at any precision less than what I'm doing. I try to keep my Gerbers and NC always at the same precision. Just eliminates headaches, basically, more than anything. Okay. So that's how you would write out Gerber and NC from Gerber import. I could also create ODB++ from Gerber import. I can create 2581 from Gerber import. The uniqueness of those two formats is it does not require component information. It supports it, but it doesn't require it. If, for whatever reason, I was trying to create a CAD database, and maybe that's GenCAD, the two grayed out ones, or PADS ASCII, those formats require intelligent formats, require components to be present. So you have to do a lot of work in order to export those formats. Basically, you have to reverse engineer the design. So you're probably not going to do that. So if you were thinking about writing out a CAD format from Gerber and NC, there's a lot of work that goes into that. Basically, you've got to clean up your data, make sure all traces end in the center of pads, and then build components. And then once you've done that, several checks you do along the way, and then you would export, if you had those capabilities, these CAD formats. But again, the advantage of ODB and 2581 is I don't need to have component information. But the disadvantage is I don't have component information. So if I'm trying to take it back into a CAD system, it probably won't come in. All right, so that was export. Let's talk about importing other formats here. So I'm just going to do a new document. And I'm going to import, let's start off with ODB++. So we will support it whether it's, a TGZ, which is their standard format. We'll also support it if it's just a directory, which is what this one is. And we'll even support it if it's a zip file. Altium does zip files. So if you get ODB from Altium, a lot of times it's zipped as opposed to TGZ. And just as an aside, if you're wondering what .tgz is, it's the old Unix zip and tar commands combined. That's where they got the extension TGZ. So any of those we can bring in via the ODB importer. You just hit import, and it'll go ahead and bring in your design. Okay. So this is our new rigid flex demo board that we're including in 14.5 and above. But I just wanted to show you that you can bring that in via the ODB, even though it was a directory structure. Now, along with that idea is you can import IPC 2581. You're probably not seeing much of it, but we do support it. So if I go out here and find a 2581 file, It's just as simple. All those steps I did when I set my layer sets and I set my, you know, what layers the drills went through. I labeled my layers, and then I imported an IPC netlist. All that was done just by importing this either ODB++ or IPC 2581. You notice all the layers are defined. And if I go to layer sets, you'll see they're defined. If I go to the stack up visualizer, you'll see that it shows which layers the drills go through and so forth. So that's the advantage to intelligent data. And when I say intelligent data, I mean ODB++, IPC 2581 versus Gerber data, which is just XY coordinates and shapes. Okay, and then writing it out is basically the same. I just turn around and export, and again, if I brought in Gerber and NC, I could do it, or if I brought in ODB, I could create either ODB or 2581. All those options are available to me. Okay, so that's importing and exporting of quote-unquote intelligent data. So one of the last questions was best way to get Gerber verification and how to get a report. Well, I've already really covered that in that my opinion, and this is just my opinion, the CAM view option is much better than a text report. Text reports to me are useless. So I prefer to, when I load something like this, one that we had here before, and I run analysis, I would just save the .cam file, and then that .cam file becomes your report file. But having said that, I'm going to show you how you can do a report out of CAM350. All right, so we're going to go back to the Air Explorer here, and as you remember, I ran this analysis earlier. And what I can do is I can go to Air Report, and this gets really busy, but if you really want a text file, you can do it, and you can break it down by all the different checks that you ran, which individual layers, which routines, okay, and then you can export that as either comma separated, or you can just send it straight to a printer. So yes, you can do a text file. Personally, I think it's pretty useless, but hey, if that's part of your procedure, you can still do that. Better to me is to use CamView as a more intelligent way to look at the results of analysis. And then the last item here is how to obtain different layers and save them on a PDF file. I think all you're asking is how to print a PDF. That's pretty straightforward. Is just go File, Print. Again, you'll have options here. Right now it's defaulting to the layer that's turned on. I can center this data in there, or I can fit it to the page. I can rotate it. I could do it in landscape versus portrait. But the last step is you pick the plotter that you want to send it to. Instead of printing it, I'll just send it to a PDF writer. And Qt PDF works just fine. I happen to have Adobe on this system. And you just say OK, and it's going to go ahead and write that out to that particular format. I could do something like this, center them all. We'll turn the fit off. Maybe I want to tile them, you know, and print them all to one page or something like that. There's lots of options, I guess is the point. The one thing that people do kind of miss from the other one is print display. And that was a separate menu item, but you do it in this menu in this release. And then again, whether you want to send it out to a printer or you want to send it to PDF, you just hit OK and it goes ahead and creates it. But that's how you can print out layers in this particular one. Okay. All right, let's talk about the panel editor and the fast array module. So what you have is what's called the fast array module, and you get there through tools and panel. All that's saying is I didn't supply a separate datum for this data, so it's going to use the same datum that it did in the CAM editor. And if I go to panel setup, it starts walking me through the process. Now, notice that a lot of this is grayed out because this is the fast array module. What I can do is enter a panel size, and then maybe image spacing between my PCBs and maybe a border around it. And then I hit panel create, and it'll show me how many will fit on that particular design given these parameters. Okay, and I can change things. I can try different rotations. Let's see, right now I'm getting 24. Looks like I still get 24 with a different rotation. It's pretty square board. Maybe I don't need 1 inch all the way around it. You know, I can put a 1/2 inch and see if that does anything for me. It doesn't look like it does much. And then when I'm done with that, oh, I should show you there is a spreadsheet mode where you could put boards in here, you know, and move them individually if you want to. But for right now, and then I could have it recalculate the panel size, but generally that's not what fabricators do. Fabricators have set panel sizes, and they're going to fit the boards on that set panel size. So 18 by 24 in this case, I hit OK, and it goes ahead and steps the data. Now, if I wanted to take that further, I could simply add features here, whether that be a decode or maybe a custom aperture. I could add fiducials, things like that. Tooling holes I could add through the insert option. So I could insert a hole. I could create a mill program with a mill path and then add tabs to it. If I wanted to, those things are available to you in the NC area. By the way, there is no more NC editor. It's all done in the CAM editor or the panel editor in this case. Okay, so that's panelization in the 160, and then you could, of course, export in panel form. Again, you'll notice that when you do this now, you can tell it what to scale and what not to scale, and you can give it a scale factor and then choose to export it. So in the fast array module, you cannot save panel sizes. In the panel editor, which you do not have, you can save panel sizes. So I can put the other license back in here at the end, and we'll take a look at that. I want to show you one more thing here, and then we'll do that. So if you'll just hold that question for a second. The second question was how to use dimensioning, and my flippant answer to that is we don't have dimensioning in CAM350. We have another tool, Blueprint, that has dimensioning. But there is an old macro that's been around there for 25 years that does dimensioning. You're welcome to use it, you're welcome to modify it, but I'm going to tell you up front, it doesn't work that well in this release. It worked fine in 12.2, and there's actually a defect written up on it to fix it, but we just don't get a demand for it because, quite frankly, our users don't do dimensioning in CAM350. But I want to show it to you and show you how you can still use it if that is something you want to. So under the Tools ribbon, under Play and More Macros, you can get to Auto Dim. Okay, and there's different types of dimensioning. I'm going to use the basic datum type dimensioning. You'll probably do millimeters. I don't think that part matters, but anyway, I'm going to say OK to that. And it tells you to follow the prompts. Well, that's the problem. That's the bug, is there is no prompt right now. What it's looking for is where do you want the datum. So if I left click there, you notice it puts there, and then right button to confirm it. And then the next question really is where do you want your text to go. and then where do you want additional dimensions. So I'm just clicking left and right buttons here. So my recommendation is if you still have 12.2, kind of write down the procedure that uses, and you can still use that to run this macro in 14, even though, as I said, it is not putting the proper information down here for you. But it still works, it's just not putting the proper information. If that's what you're using it for, I don't know why you're using dimensioning in CAM350, but if that's it, you just have to be aware that you have to know how to do it, that the prompts are not going to help you. And you can always reference back to 12.2 to see what order you click in. All right, so we're back to this one again. Now I have the full license in there, so let's see. Let's do the measuring first, then we'll go back into the panelization to answer your question. So under the measure ribbon here, point-to-point measuring works in conjunction with your snaps. So I have object snap turned on, I have grid snap turned off, and grid visibility turned off. So if I want to do point-to-point, I can just click here in the center of that particular pad and then click in the center of that pad, and it gives me the distance between the two. Okay, and I've got it on there with conjunction of object snap. Now, you may want to make your scan box bigger to make sure that you get the center of an object. So I did that with the page up button, and again, this is in the help, but as you can see, when I do that, again, I get the same measurement, but the page up and page down increase the size of your scan box when you're doing this. So you may find that useful. You know, I've gotten to the point where I just get used to it and know if I click close to the center of this, that it's going to get the center. If I click way over here, it's not going to get the center. But if I click here, close to the center, and I follow the prompts down here at the bottom, it'll tell me, you know, what the distance center to center between two items is. Now, that's one way of doing it. But then there's also, what's the distance between objects? So again, I can do the same thing. I pick that object and I pick that object, and it's going to tell me what the distance between them is. And if I happen to get the wrong item, I can just keep clicking with the left mouse button until I do get the correct item. So, and that gives me the distance between those two objects. So that's basically the two measurement options that are in CAM350. Point-to-point, which I used in conjunction with object snap. You don't have to, by the way. I could have done point-to-point, you know, come in here, and I call this a guesstimate, but, you know, you could just come there and come here and just get an idea of how far it is. It's not exact, but it's close enough in most cases. But the point-to-point and snapping will snap to the center of these so that you can get a pitch of your surface mounts, for instance. That's the two measuring options that are in CAM350. While we're in here, and then we'll go back to the panel in just a second, I just want to show you the way Streams has changed now that we have the full version. So this is the DFM checklist, and you'll see that when I expand this a little bit, let's go to internal signals. So instead of you know, a total of 20 checks, I have, you know, 40 that I'll do just on signal layers. You know, I'm just kind of guesstimating how many there are. And then I'll have another 20 or 30 I'll do just on solder masks. So there is a lot more depth to the number of checks you get, I guess is my point, when you have the higher end version. So just be aware of that. All right. Without belaboring that, let's do one more thing. I'm just going to go in here and delete something. And I'm just going to go off to another layer and move something. And one of the features that I mentioned in the higher end is design compare. So the idea is at least one of the designs you're going to be comparing is saved off as a CAM file, and then you just basically browse to it. It loads it. Notice I have 40 layers over here now instead of 20. Actually 40, I've added a few more layers there, but anyway. And then it tries to map the layers. And it maps by layer name. So if your layer names are not the same, you can come over here and map them manually. But the advantage to using design compare over layer compare is I can just go and run it on everything at once. And it basically goes through and we'll find, and I don't need this, I'm just going to move it to the side though. It'll find the differences between the two. So it went through all of the layers. The last thing you can do with this is you can tell it to delete the imported design after you've run it, so that you don't have two designs in your database, two sets of data, and it'll delete the one you imported. So that's design compare. It's another part of the higher end. And then there's one last feature, again, just so you have an understanding of what's in that that higher end bundle. There's a feature called Design Analyzer. And this was originally a quoting tool. It goes out and finds the minimum line width, space, and so forth from the design, and it'll put it in a little report for you. But we actually made it friendly for designers to use, in that they can put the fabricator's capabilities in here, and it will compare what they extract from the data against your capabilities and let you know if you're able to do that. So and you just click this Analyze to Vendors button, and it goes out and does it. And it puts a checkbox where you can do it and an X where you can't. But you as a fabricator could use this as well. What you could do is have your prototype and your production parameters in here, and then use this to quote it. Or if you have, like we used to have, we had, standard runs or engineering runs where basically the spacing might have been too tight for a standard run. So somebody has to walk it down a line. You could put those values in there and compare against those as well. So this is, again, another feature of the DFM 520. Okay. All right. Any questions? I'm going to go into the panel, but any questions on anything else before we finish on the panel? Let's talk about the panel, and again, you'll need to make the decision here. I don't know how you're doing panelization now, but if I go to the panel editor and I have the full-blown panel editor, I start off the same way, but one of the things you'll see is now all of a sudden I've got some saved off panels. So I have a 20 by 24 here. It's already got some coupons saved off, or I could create one. So let's do that. I'm just going to use, sorry for using English units, but that's what I know. Okay, so we're going to leave it at that, and then I could add what we call symbols. And those symbols could be pinning holes. So basically a tooling hole, and then I choose where I want that, and maybe I want that in a ½ inch from the sides, okay, of the left and bottom, and then you could put another one in there and so forth. And the same idea with fiducials. There might be a fiducial. If I don't have any in my library, I'll show you how to create them in just a second. Coupons, if there's any coupons that you want to add, maybe some sort of IPC coupon or a drill check. This is like a first last that I can put on there as well, and then maybe I'll take that and let's rotate it 90 degrees, and then we'll put it at the center of the left side, and then we'll indent it maybe a ½ inch. Okay. and then I hit create. Okay, so well, first of all, sorry, I got ahead of myself. So then I could save this off. I have an 18 by 24, and obviously you're going to have more out in the periphery, but these are the items that I've created and added to my panel. I can save that and reuse it from panel to panel. And then when you get the data in, you go to panel create, you load that panel, you go to panel create, and then you decide, you know, how you want them rotated and so forth. And once you're happy with that, you hit OK. And what it will do is, granted, you'll typically do in a first last, you'll have two of these because it's the first drill hit you make and it's the last drill hit. It lets you know if you've broken a bit. But that's what it's done, is gone smallest to largest drill size automatically for you. And then this is just a tooling hole, a 125 tooling hole down here. Now, going along with that idea is panel venting. So this is something we don't include in the fast array because that's more for a designer creating an assembly panel. This is more for creating a fabrication panel. I may have a robber bar around my outers, and I want to keep, let's just do an inch here since I made that, so that'll be 1,000. And these are mils, sorry. So that'll be 0.3, no, actually it'll be 30. All right, so I'm going to keep it 30 mils away from images. I guess I should do 30 mils away from symbols. I want it to be 1,000 mils or an inch. And then I pick the layers that I wanted to go on and apply. And I'll just turn on that particular layer. Oh, I guess I have to hit OK. Okay, so now you can see my robber bar was added, and it keeps away the parameters that I said from the these particular symbols, is our term for them. If I go back into venting, though, I might want to add a dot pattern. So let's just do that. So I'm going to add an additional venting pattern, and I can add it to this layer or a different layer. Typically, you add that to, you know, internal layers, unless you want it for thieving purposes on your outer layer. But let's just go in there, and I'm going to do the same thing. I'm going to let it go to the panel edge, but I want to keep it 30 mils away from PCB images and 30 mils away from symbols. And it's going to be a dot pattern, and I can create the dot pattern however I want to here. You can save these and recreate it and import them, the dot patterns, but I'm going to use this one, and then I pick the layers that I want it to go on. Let's just put it on this layer here and hit OK, and I think it did that. Let's go off to that layer. And you can see that it created the dot pattern around there, and it still did the keep away. Okay, and it actually put these here and here. Notice that those are partials. That's something that's bad, so you probably don't want those. The idea is that you create your dot pattern, you get it the way you want it, and then as the last step, you'll go in and say, sorry, I get the right one here. You'll turn off this allow partials and hit OK. Those go away anywhere where it created those slivers, so it only puts full dots out there instead of creating slivers, so you don't have problems. Okay. So the last thing I want to explain in this is the, go back to tools here, is the symbol creation in the symbol editor and how this works. So we've got some symbols here, and you can create your own. Let's just dock this. All right, and the idea with symbols, let's just say I'm going to start creating my own here, instead of using one of these existing ones, is that they can be made up of different features. So if I want to put a symbol out there, and let's snap it to the grid. So we'll put it right there. Now, where I put that is key, though. I put that on this particular layer, top layer. And your symbols can go on any layer, and it's remembered. So if I wanted this to go on all of my layers, I could use the copy command and copy it off into different layers. Okay? And the layers here are not what you're used to seeing, because you generally will do this without a design loaded. This is generic layer names. So I want this dot to appear on the top, and if I want it on all layers, I would just check every layer, or maybe I just want it on the top and the bottom, so I just copy it over to the bottom layer. Okay? So now, if I'm in my view and I want to see the bottom layer, I can turn that on and see that, you know, it's there. And then as I exit here, this design process that I'm doing here, as I exit from here, it should prompt me. Let's see if I go back to the CAM editor. No, it didn't prompt me. That means it's still there, though. So if I go back in there, panel, and then tools, and by the way, you have to go to the panel first to get to this, to get to the symbol editor. Okay. And this is a symbol type. You know, I can set, if this was a coupon of some sort, I can set it as a coupon, or I can set it as a pinning hole, or probably this is a fiducial. That's okay, but all that really is a placeholder. All these are basically the same, but they're just, we've made it so that you had a way to look at, you know, which ones these are. So you notice that as I click on these, it changes which category they're in. So if I now go to save symbol as, it prompts me, I can either add a border around it so that when I do venting, it keeps it away, or I can just let it come all the way up to it by doing a save data as. Okay, then I give it a name. Now, this is kind of old school in here, in that these names can't have spaces in them, so kind of silly, but they can't. So we're just going to call this FID1, and we're going to save it as a fiducial and click OK. And now we're going to get out of the symbol editor, and we're going to go back into the panel editor, and I could go back into create if I wanted to, or excuse me, setup, and add FID1, and then place it, and that whole process I did before, basically add it to my panel, and then it can be saved as part of the default panel. So the process really is that you create your panelization here over in the symbol editor, you know, any kind of special coupons, tooling holes, fiducials, post-etch punch coupons, IPC coupons. You can create those here. You add them to that default panel back in the panel editor, and then you can save that and reuse it from design to design. And that's the whole idea behind the panel editor. And the difference between the panel editor and the fast array module is basically the whole idea that I can save and reuse panels and venting patterns, I guess, and symbols. I believe there's a tutorial on this. And it may be, I don't know if it's been updated for the latest release, but there should be a tutorial in here for panels. Okay, so there's your tutorial. And I think, I'm pretty sure that if you go off to our website and look at the copy of it that's there, it actually has graphics in it as opposed to the one that's in the help system. They just didn't get the graphics in there. But yeah, there is a tutorial in the help system for creating a panel with the panel editor as opposed to the fast array module.
Thank you, people. Thanks for your time. And thank you, Ray, for taking this.